Naval Air Facility, Midway Island, was commissioned in 1941. Because of military drawdown, the base was designated for closure under the 1993 Base Realignment and Closure Act. Naval Facilities Engineering Command has been tasked with performing an extensive environmental cleanup and base closure process here on Midway to prepare the island for turnover to Fish and Wildlife Service so that they can operate a wildlife refuge. The cleanup process is anticipated to last until mid-1997. To help assist us with this cleanup process, we tasked UCT-2 to come out to help us out with a couple projects. Specifically, they demolished a water tower here on Sand Island and demolished sheep piling over in Eastern Island.
Well, besides the sheet piling, which is primarily for Fish and Wildlife, was to provide a clean beach area for the wildlife to be able to enter the beach area. The other project was the tower, which you see behind me here. And basically that was a 119-foot tall water tower that was they wanted to demolish to prevent it from being a hazard to low-flying birds, especially the albatross when they start migrating back here. What we did was we measured around each of the legs of the tower, and so we could get the exact length of explosive charge that we needed. We also cut all of the supporting tiebacks and bracing that would help for, I guess, latitudinal bracing. And also we cut out a big 8-foot chunk out of the middle section of the water tower. And then basically we designed the explosive charge pattern back when we first did the pre-site survey back in October of last year. And it was just a matter of hooking everything up in a series with delay elements and detonating cord and just all blasting it simultaneously. What we used was to sever the pipes of the legs of the tower was what they call explosive cutting tape, which is a low hazard shape charge, which is can be placed around like a cylindrical object or a flat object. We taped it into place to get a good solid contact, and then we primed it with a detonating cord and a small booster charge. This was hooked into a mainline system, and then we had C4 explosive charges behind the legs so that when the whole system detonated, the two forward legs would be severed and would be punched out by the C4 charges, with the back legs of the tower being severed a millisecond later by the delay element. Okay, we're still closed. Okay, open. Okay, close. Okay, wave off. Thought it turned out very well. The tower fell in exactly the direction it was designed to. There was no flaw in the placement of the explosives, the makeup of the explosives, or the preparation of the explosive charges. So everything went as textbook as could be expected.
Well, my understanding is that the Navy, using their in-house underwater construction team, was able to utilize their assets effectively to be able to remove the seawall, which we, U.S. Fish and Wildlife Service, and another partner, National Marine Fisheries Service, we have requested the Navy remove the seawall because, as you can see, as the seawall deteriorates, eventually it will pose an entrapment hazard to the endangered Hawaiian monk seal. As a Hawaiian monk seal hauls out on the beach to rest during the day after a night of feeding, it could eventually get up behind the seawall and somehow get trapped. During the operations, we do have to be concerned about the shock wave from the explosives going out into the water and posing a harmful effect on the marine life that is in the area. For example, if a monk seal that we're trying to protect in the long run happened to be transiting through the area when the blast went off, the shock wave could certainly injure or cause death to that animal. We certainly want to prevent that.
Well, UCT-2, Ardette Charlie, was tasked with coming out here to Midway Island, going over to Eastern Island, which is a adjoining island nearby, and taking out a quay wall, which is all part of putting the base back to a natural state for the environmental purposes. Before we could place the explosives out there, we went over to the seawall and we had to prepare it, and this entailed using scrapers, brushes, wire brushes, and other assorted tools to make sure the area was clean to get a good contact with the explosives to the wall. Another thing we had to do was make up quite a few sandbags. This was used for placing on the explosives for holding a good contact against the wall. The RSO will go through the safety brief, telling everyone what he expects, what the evolution of the day will be as far as safety. At that point, they take what they call a Bravo flag, and they will raise it for everyone in the area to see. We also would use what we call a shark watch, and that person is basically there just to keep a lookout. If he were to see any sharks or anything in the area which needed attention, he had a radio and he could notify the divers, dive soup, or whoever was in the water. We also brought along what they call a shark dart. We had someone in the water which was designated as shark dart person, who had the shark dart, and if a shark was seen and got too close to the people at work, he was able to use that shark dart and keep the sharks away. In the studies and finding out which explosives might be best for this job, they came up with the use of ECT, which is explosive cutting tape. That is a type of shape charge used to cut metal. They also opted to use data sheet, which is more for a shattering effect. Between the two, we were to be able to cut the wall and get a good clean cut and take out what we needed to take out. When using the ECT for preparation purposes, we experimented quite a few different ways. One of the ways that we used the ECT was cutting it into sections approximately 12 inches long. After we cut the sections up, we then took the deck cord, placed a booster on it, and primed into the ECT charges. It was similar using the data sheet. Data sheet comes in approximately sheets of 10 inches wide, 12 feet long. We'd unroll the data sheet, cut it into sections approximately 2 inches wide. At that point, stacking them depending on the size of the explosive we wanted. Could range anywhere from 3 thick to 10 thick. After rolling the data sheet together, taping it all up, we then, similar to the ECT, prime it using det cord and booster. In order to make good contact, we used rebar, sandbags, wire, stovepipe wire, whatever we could find to get a good placement, good firm contact against the metal surface. At that point, we used det cord. The explosives were already previously made up. Det cord with a booster already attached. We'd come back, run the det cord, attaching it with white devils, what they call it, using a main line and branch lines. At that point, we'd come back with our no-nell, which is a non-electric blasting cap, and cap in. Once capped in, we'd ensure that everyone was back at the safe area, get a good head count. Communications would be with the RSO. At that point, once you're capped in, they'd sound the siren, letting everyone know in the area that the explosive would be let off, giving 3 short fire in the holes, and at that point, we go ahead and do the blast. Okay, in using the explosives, we started with a small amount, gradually increasing to get the desired result. Unfortunately, what we ended up doing was we were getting a shattering effect due to the debris, rock, dirt behind the wall. The end result obviously wasn't what we were hoping for. We would have to end up using more explosives than what was originally planned or feasible. We had environmental issues to be concerned with, and obviously using more of the explosives would impact the environment in a negative way. We now feel that an alternative to the explosive technique would be to come back with underwater cutting capabilities and take out the wall that way.